Okay, so just to recap, the difference between the DeMoivre or uniform distribution assumption for future mortality and the generalized DeMoivre, also referred to as the beta. So for the uniform distribution, we assume that the future lifetime of a newborn is uniformly distributed over the next omega years. Omega is some big number like 100, right? So we assume that T0 is uniform. And we saw in class that this implies that for an X-year-old, the future lifetime will also be uniformly distributed, but now the future lifetime would be at most omega minus X years. Our knowledge of the uniform tells us that the density is just going to be 1 over the length of the interval. So for an X-year-old, it would be 1 over omega minus X. And the survival function is going to be 1 minus T over omega minus X. And we derived a formula for the force of mortality. That is also 1 over omega minus X. And then we know that the expected value of a uniform is just the midpoint of the interval, so this is just going to be omega minus X over 2. Okay. So for the generalized DeMoivre, you can just remember that the survival function now is going to be almost the same, except that we're going to raise it to some power alpha. So if alpha is 1, we get our uniform. And for the force of mortality, we get alpha over omega minus X. And for the expected value of T sub X, we get omega minus X over alpha plus 1. So you can see if alpha is 1, you just get the formulas that we wrote down for the DeMoivre. Okay, so let's look at a simple example. You're given that the force of mortality is 0.5 over 100 minus X. So you should immediately recognize that as the form of the force of mortality for a modified or DeMoivre, right? A generalized DeMoivre. So alpha is 0.5 and omega would be 100. And we want the probability that 36 survives to age 75, so we want S36 of, let's see, 75 minus 36 is 39. So that a 36-year-old survives 39 additional years. And for the DeMoivre, it would be 1 minus T, so 39, over 100 minus 36. But this is the generalized DeMoivre, so we have to raise that to the alpha, which is 0.5. So we just get 1 minus 39 over 64 to the 1/2, or square root. And if you work that out, you get 0.625 is our answer. Alright, we'll just do a couple problems from some old exams. So here, sort of the same kind of formula for mu sub x. We have mu sub x is equal to, let's write it as 1/3 over 100 minus x. So again, you can recognize that as the form of the force of mortality for a generalized DeMoivre with alpha equal to 1/3 and omega equal to 100. And we want the probability that a life age 70 will die between ages 75 and 80. So that means we want the probability that a 70-year-old will survive to age 75, so will survive 5 years, but will not survive to age 80, so will not survive 10 years. So we have to take the difference of those two survivals. And again, we remember how to compute the survival function for this situation. We're going to have 1 minus t, which is 5, over 100 minus 70, right? So 100 minus 70 to the alpha minus 1 minus t is 10 now, over 100 minus 70 to the 1/3, and if you work that out, you get about 0.067, which would be answer C. All right, in this problem, they tell you that mortality follows Maycomb's law, and which of the following represents that integral. And really, this is kind of a trick question because it doesn't really matter what the mortality law is. We remember that TPX mu x plus t is another way of writing the density of t sub x, no matter what the mortality law is. So what they're asking you for is the value of this integral, but if we integrate the density from 1 to infinity, that means that we're just computing the probability that the random variable is greater than 1. In other words, we want the probability that an X-year-old survives 1 year. So it's choice A. All right, and then my last example in this video is going to be this problem. We're given that mortality is described by Weibel's law, which you're told is mu sub x equals kx to the n, and you know what k is and you know what n is. So what do we want? We want the probability that a 40-year-old will survive to age 42, so we'll survive 2 years. And since I'm given the force of mortality, I know that I should do e to the minus integral of mu sub x from the current age to the age that we're surviving to. Mu sub x is k, 1 over 100, x to the n, so x, n is 1, so x dx, and that's a very easy integral, so this would be minus 1 over 200 x squared from 40 to 42. So we're just going to get here 42 squared minus 40 squared, and you can work that out. You're going to get about 0.44. So the correct answer here would be D.